to Unit 12, topic number 1. We're going to talk about trigonometric ratios, and this word SOHCAHTOA is going to become your best friend by the end of this video, okay? So before I get started on actually diving into the trig ratios, I want to talk about 3 very important words. In this video, when I say the word opposite, I mean the leg of a triangle that is across from a certain angle, okay? So opposite and across. When I say the word adjacent, I mean the leg that is next to an angle, okay? There's a little bit of a typo there. And when I say the word hypotenuse, we've been all really familiar. That's the side of a triangle across from the right angle, okay? So before we actually dive into sine, cosine, and tangent, let's just work with certain angles and find the opposite, adjacent, and hypotenuse sides. So given triangle ABC, label the hypotenuse and the sides that are opposite and adjacent to angle A. So let's circle angle A over here because we're now living, I'm going to say this, in angle A world, okay? So angle A in the triangle is all the way up here. I always like to start by finding the opposite side of angle A. So I just draw an arrow from angle A across, and 12 is its opposite side. I'm going to label that OPP. And then I like to find the hypotenuse because I think that's the next easiest side to find. So the hypotenuse is the side across from the right angle, which means I'm going to find the right angle, draw an arrow across, and label that HYP for the hypotenuse. And then the last side has to be the adjacent side, right? Well, the adjacent side is the one that's next to, so the one that's sitting like, if this is angle A right here, it sits next to it, and it's not the hypotenuse. So there are 2 sides that make up angle A, the hypotenuse and another leg. That other leg is the adjacent side. I'm going to label that ADJ, okay? So that was when we were living in angle A world. But now, let's look to the right. It says, given triangle ABC, label the hypotenuse and the sides opposite and adjacent to angle C. So now we're living down here in the angle C world. Let's do the same process though. Let's find the opposite side first. I'm going to draw an arrow across. That side's opposite. Okay. I'm going to draw the hypotenuse. Go to the right angle, draw an arrow across. That's the hypotenuse, 13. Label that HYP. And then the final side, the side that's next to angle C, is the adjacent. And notice what happened here. The hypotenuse stayed the same. But when I changed the angle, the opposite sides and the adjacent sides kind of flip-flopped, okay? So we have to be very careful moving forward about thinking about what angle, like what world we're living in when we're taking these trig ratios. All right, now let's actually look at trigonometry. So trigonometry we define as a way to just describe relationships between sides and angles of right triangles. So it's very specific that it only works for a right triangle, okay? For any acute angle, I'm going to use this weird notation, theta. That's going to mean angle in these equations that we're going to set up, okay? So it has to be an acute angle, which means it does not work for a right angle. So for any acute angle in a right triangle, we have the following trig ratios. We have sine, cosine, and tangent, okay? So sine, we're going to abbreviate SIN. And whenever we have a trig ratio, we always input with an angle. So sine is always going to be the ratio between the opposite side. Actually, I'm just going to abbreviate opposite OPP and the hypotenuse. So if I had my angle, let's say we're thinking about angle A down here, sine would be the opposite side over the hypotenuse, and this will make more sense as we do some more examples, okay? Cosine, we're going to abbreviate that as COS. So cosine of theta is going to be the ratio adjacent side over the hypotenuse, okay? So the adjacent side to the angle would be here, and the hypotenuse would be above. And then last but not least, we have tangent. And tangent, we're going to abbreviate as TAN, of theta equals, and it's going to be the opposite side over the adjacent side. Okay? So we have a nice little memory trick down here, which I call SOHCAHTOA. And I would say SOHCAHTOA over and over and over again until you know how to say it, you know how to spell it, and you can use it every day in class. So the first letter means sine, cosine, tangent. Okay, that's the S and the C and the T in SOHCAHTOA. And then the second letters tell you what the ratios are. So OH means opposite over hypotenuse. AH for cosine is adjacent over hypotenuse. And then OA for tangent is opposite over adjacent. So it's a good memory trick to remember what these trig ratios are. Let's actually get to some examples. So these examples we're going to have to use our right triangle skills from back in Unit 8. Okay, so it says use the following triangle to find sine of angle C, cosine of angle C, and tangent of angle C. So looking at this problem, I have a right triangle and I have three side lengths, 6, 8, and 10. Okay? In the practice problems that you're going to do, you might not have all of those side lengths. So if you're missing one, we know, and we're all really good at using the Pythagorean theorem to find the missing side. Okay? But now let's look at the actual trig ratios. Part A says sine of angle C. It's very important to remember that we're focusing in on angle C and we're in that world. Okay? So I would like everyone on the top of their paper to write SOHCAHTOA, because we're going to use that to help. So A says sine. Well, sine is the S. That means I'm going to do opposite over hypotenuse. And so I'm going to come over here to angle C and find its opposite side. Well, the opposite side is 8. And the hypotenuse, well, we can label that because that doesn't change. The hypotenuse is 10. So this ratio is 8 over 10. And now we have to simplify it. Divide by, I think, 2. And we get 4 over 5. All right, let's look at the next one. So the next one says cosine of angle C. We're living still in the C world, but now we are finding the cosine, which is the ratio A over H. Okay? So adjacent over hypotenuse, well, over by angle C, the adjacent side is 6, and the hypotenuse is 10. So this ratio is 6 over 10, and we can simplify, divide by 2, and I get 3 over 5. And that's my answer. So whenever you're taking sine, cosine, and tangent of an angle, your answer is always a ratio of two sides. So last but not least, we have tangent. Tangent is TOA, OA, so opposite over adjacent. So again, our angle is C, so we're going to find the opposite side of angle C, that's 8, and the O over A, and the adjacent side is 6. So it's going to be 8 over 6. Divide by 2 again, I believe that will simplify down to 4 over 3. Okay? Let's try number 2. Okay? Use the following triangle to find tangent of H, sine of B, and cosine of H. So be very careful here. That angle switches. So we're going to talk about that in a second. But first let's look at our triangle and notice that we have some missing sides here and here. Well, I know from past units that this is with an isosceles right triangle is a 45, 45, 90 triangle. So the relationships between the sides are x, x, x root 2. And if I use the information that they gave me, I can find out that x is going to be 6. Okay? So that means that these two side lengths here are 6 and 6. Now we're ready to find the trig ratio. So tangent of angle H. So we're living in H world, which is down here. Okay? So H tangent is the TOA, that's O over A. So I need the opposite and adjacent side to angle H. So the opposite side is 6, and the adjacent side is also 6. So my ratio is 6 over 6, which will simplify down to 1. Let's find sine of angle B. Now notice the angle here changed, and I'm living up here in the B world, okay? But sine is opposite over hypotenuse. So the opposite of angle B is this leg 6, and the hypotenuse is 6 root 2. So 6 over 6 root 2. And we can actually simplify this down. There's a factor of 6 in both the numerator and the denominator. So that will be 1 over root 2. And there's my answer. Okay? Now let's find cosine of angle H. Be careful, we're switching the angles up again, so we're back down here in the blue, the H world. So cosine of H, cosine is adjacent over hypotenuse. The adjacent side to angle H is 6, and the hypotenuse is 6 root 2, so I get 6 over 6 root 2, which is the same ratio. It will also simplify down to 1 over root 2 if you divide by 6. So 45, 45, 90 triangles are pretty special. You'll see this 1 over root 2 very often, okay, in almost every single 45, 45, 90 triangle. Let's look at the last one. Now we have our 30, 60, 90 triangle, okay? So let's find the missing sides. Across from the 30 is the x, across from the 60 is our x root 3, and hypotenuse is 2x. I know that x is 10, so my side lengths are 10. 2 times 10 is 20, and x root 3 becomes 10 root 3. Okay? So now that I have my 3 sides, let's find our trig ratios. Tangent is that TOA, so that's going to be O over A. The opposite, well, we have to figure out what angle we're working with. We're working with angle D, so I'm over here. Opposite of angle D is 10 root 3. And adjacent to angle D is 10. Okay, I can divide by 10 in both the numerator and the denominator. And I'm left with root 3 over 1, or just root 3. Okay, let's find sine of angle H. Now notice I switched the angle, so I'm down here living in the H world. Sine is opposite over hypotenuse. Well, opposite of angle H is 10. And the hypotenuse is 20. I can divide by 10 in both the numerator and denominator again, and I can get 1/2. I'm going to write that down here. Okay? And then last but not least, let's find sine of angle D. So I'm finding the same trig ratio, just sine, but it's a different ratio because I changed the angle. We're up in here finding the sine of angle D. So it's still going to be opposite over hypotenuse. However, the opposite side is now 10 root 3. The hypotenuse hasn't changed, though. It's still 20. I can still divide by 10 in the numerator and denominator. And I can get root 3 over 2. And there's my answer. Okay? So good luck practicing, or good luck on your homework, and I will see you in class.